All right. So we've covered a lot of ground. We've covered querying, right? We've seen excuse me, excuse me. We've seen aggregate functions. We've seen the where clause. We've seen group by. We've seen how the where clause and group by work together, and along with where we've seen limit and order by and and as for alias and columns. And once you start to combine these, we really get cool stuff happening. Now we're going to talk about joins. And the goal of a join is to get data from multiple tables simultaneously. And I've made a new file here, right? So a join is how I can use a single query to get data from multiple tables and how I can connect that data between tables based on their relationships, i.e. the foreign keys. So for example, I want to get a list of cars and their drivers. And I have the car table, right, which has ID, make, model, and the driver ID, which I'll just put over here as driver. And I'll just put the first three on here. We'll do the first four, right? And we got a Toyota, we got a Ford, we got a Honda, and we got a Chevy. And in fact, I'm not even gonna, and we got Camry, an F-150, an Accord, and a Malibu. And we have driver IDs of 1, 2, 1, and 3. Right. So one driver has two cars here. And I'm gonna build out this data a bit, right? Because this visualization is going to be really helpful to break down what the join is doing. So I've got my cars table and I've got my drivers table, right? And for my drivers, and is this font size good for everyone, by the way? Cool. Got ID and name, and we're not going to worry about the other driver fields. And I've got 1, 2, 3, 4, 5, right? And we have Michael and Alice and David and Emily and John. And I want to get a list of cars and their drivers. So I want to see something that looks like this. I want the car ID and, make, model, driver, and I want the driver ID and their name. Right. And so for car one, my Toyota Camry, I want to see that it belongs to Michael. Um, and these are in order here in my example, but in the data, who knows how the database has stored them, right? Um, and so car two, the Ford, well, that belongs to the driver with ID of 2 down here, Alice. So I want my result row, my result table to look like this. Car ID of 3, the Honda Accord, also belongs to driver with ID 1, so that's Michael. And then car 4 here, our Chevy Malibu, belongs to driver ID 3, and that is David. Right. And again, it is our primary key of our driver ID. And there we go. There's my pane that I was looking for. or rather the foreign key of driver ID that connects up to that primary key. And that's how we're going to do this. And if I look at my schema real quick and we look at our, let's go down, we see we've got driver and it's a foreign key that references the driver table and its ID column, which is the primary key. And let's find our driver table. And here's our driver table, and we see the ID primary key. So this is what a join is going to do. And I just want to check in to see if folks have questions conceptually around what we want to accomplish here. Cool. So the next question is, how do I do this? And the good news is that initially this is straightforward. I can use the join command, and the way to build this out is step by step, as with all queries. So let's just say I want to get, I want all car info and I want the driver name. So let's do select. And the first problem is I have two tables. So if I say ID, is this the car ID? Is this the driver ID? Which table is this column from? So I have to specify the column I want, or the table and the column. All right, and let's do car ID, and let's do car.make, and let's do car.model, and let's do car.driver, because why not? But I want more. I want driver.id and I want driver.name. Now, where do I make this selection from? Well, I'm making it from my car table, but I need to connect that car table. I need to join it to the driver table. So we're going to say join driver, and I need to tell Postgres how to connect these two tables together. And this is where I need to connect the foreign key to the primary key. So I need to say driver on car.driver equals driver.id. And this is now my join query. And if we hop into pSQL and run my joins SQL file that has this query, let's see how we do. We see that we get our data, right? And if I look, and I included the IDs here so we can visually confirm, we can see that indeed Postgres has gone ahead and joined these two tables together based on the rule I provided here, connecting the primary key and the foreign key. So let me just pause here and see what questions folks have or what people are curious about, because this is like the essence of a join. Alex, yes, sir.
Is are the tables interchangeable? Would you be able to do from driver, join car? You get what I'm saying?
I do. That's a great question. Yes, with an asterisk. Right now, we can do this. In just a minute, we will talk about how this actually produces a different sort of join. For this specific join, that works fine, but in a minute, we're going to talk about left and right joins, and we'll see how in other situations this causes the join to behave differently. Yeah, great question. I think a good rule of thumb is for joins, think left to right. Start with the table you want to join from on the left. and put that in your from and the other in the join. Because as we kind of build this up, we'll see that depending on how we play around with this, it can produce different results. But this is sort of your bread and butter join, and this will cover like at least 50% of what you want to do with joins. Tom, yes, sir.
Can you break down your join statement? Like, where is driver coming from? That looks like an alias, but it's not really declared anywhere.
Right.
Um, and because I see the relation, car dot driver equal driver ID, but I didn't see any alias declaration or declaration.
Yeah, that's a good point. So these are both table names. So the same way how in the from clause I say what table I'm querying from, with the join, I say what table I'm joining to. What might also be confusing is in our driver table, or excuse me, in our car table, the driver foreign key is just named driver, and I think this is kind of confusing. We should actually update this so it's driver ID, and that's the naming convention you usually see for foreign key columns. I think that might be causing some of the confusion. Is that sort of what you were wondering about?
Yeah, that helps. So join driver, that's actually the table name.
Correct. Exactly.
Okay.
Exactly. Yeah. And that touches on a good point, right? We use a join to connect two different tables. So we say from table A, join table B on, and then we are almost definitely doing something like this. ID equals, table B dot, foreign key, whatever the heck our foreign key name is here. So this writing it out this way might be a little confusing, but I think the key thing is we join from one table to another, and then we tell Postgres how it has to connect the dots. And we're connecting a primary key to a foreign key, or in this case, a foreign key to a primary key. Let's look at another example of a join. And I think what I'll do is I'll make a separate file because I don't want to comment this out and have it kind of like mess up all the comments. So let's just do touch joins to dot SQL. And up here, let's open up joins to, and let's build out another join. So we've seen cars and drivers. Let's join cars and services. So let's see what cars have what service. Or let's rephrase this. Let's see what services are have been done to what cars. So let's select, and let's do service dot star to see, to get all service table columns. And we're going to want to see for the car services, let's look at the car.make and the car.model. And we're going to go from, and this is where it's going to actually kind of get interesting, because if I want to see what cars have been serviced, I can't jump directly there, right? I have services, I have cars, and I have this join table in between. So what I actually kind of need to do is I've got service, and I'm going to write it a little differently so we can see it here. And let's say service name, and let me pull up services as a reference here. We'll say name of service and ID. And over here, I have my car service table. And this is going to have my service ID and car ID. And over here, I have my car table. And this is going to have an ID. And let's just give it like a make and a model. And let's scroll down a bit here and maybe make this, hopefully everyone can read this okay. And again, what I want to end up with here is, something like this. An oil change, ID 1, who has an oil change? Some car with ID 1 has gotten an oil change. And if I hop over and I look at my cars, I see that that's the Toyota Camry. If we look at our next service, the brake inspection, which has ID 2. Well, let's look at this car services table that tells me who's done what. And we see with the brake inspection, it looks like it's the car with ID 2 has gotten the brake inspection. And that car is a Ford F-150. And let's find, I'm going to hunt around here. I see that the car with ID 2 also got an oil change, right? If we look at this column here, the service ID is 1, the car ID is 1. So over here, I'm looking at, we're actually going to see another result here. And we'll talk about why there's some duplication here in a minute. But what I'm seeing is, again, right, these things are getting chained together. And so I actually need to use two joins to connect service to car service to car. And let's see what this query looks like. I'm going to want to see just all the information about the service and the make and model of the car. And we'll worry about adding in and viewing some of this car service join table data later. But we need to connect these tables together. So we're going to join the service table on car service dot service ID equals service.id. I need to join again on car service.car ID equals car.id. Right, so we need to connect car service to service, and we need to connect car service car. And let me give us a little room so that when we run this query, we can see a nice clean result. And fingers crossed, we can run the query. And we see our results. Right. And so again, what Postgres is doing is it's connecting rows from different tables based on those foreign keys. And so a join lets us grab data across multiple tables and organize it in a sensible way. And note how we see all this duplication here. And that's because Postgres is just connecting the data together. And so we see a lot of duplicate results because, and we'll talk about different ways to organize this in a minute. But what might help is let's select car service.id and let's give this an alias and let's call it just car service ID. And I think that will help drive home what we're seeing here and why there are duplicate tables. And now I do need to move this around so we get a slightly better thing. And so here we can see, remember that each of these is like a specific service applied to a specific car, right? And we can kind of see how all of these are then joined together. And in fact, let's maybe play around with this a bit more. We could, if you want, I could add extra IDs to help connect the dots, but I'm kind of doing a lot of talking. So let me actually just check in and see what questions you guys have and what might be good for us to dig into a bit. Tom, yes, sir.
So if we can query from two tables separately with joins and get the same result as we do as from querying like this from a junction table, what's the purpose of having a junction table rather than just setting up a predetermined query from two tables instead of setting up, foreign keys, etc. for a junction table and
Right,
then a query from that?
right. And by the junction table, you mean this car service table.
Yeah.
Right. So without this, we have no way to connect the dots. And if we look at our sort of spreadsheet here, like, so this is our junction table, which I think is well put. And let's color it. If that's not there, I might have a car, right? And I might have the different services available, but where am I storing the data of when my Toyota Camry got an oil change? And that junction table, its job is to store the Toyota Camry got an oil change. Its job isn't to store information about the Toyota Camry or about the oil change. It's just to say that a car with this ID got this service.
Got it. Okay, that makes a bit more sense. I was under the impression that it was a quick way to uh, do references to children based off of certain query results. Um, so that way, like I could, instead just query this table for, anything that had oil changes and it was smart
Right,
enough and these acted as pointers
right,
rather than, etc.
right. And I think part of the tricky bit too is like it's easy to think of data as static and unchanging, but in fact, it's constantly changing. And this is also where the data model diagram can help. And what we're talking about with the join is this many-to-many relationship between car and service. If it's just a one-to-many relationship like employees and departments, I don't need two joins to get that job done, right? In fact, let's do a touch and let's call it joins3.sql. And let's open this up real quick just so we can see sort of a counterpoint. And let's say get all uh, employees in, or let's just say see what departments employees are in. see what departments employees are in, right? And so we might select employee dot first name, and let's do let's do this in order so actually we can see this nicely. Employee dot first name, employee dot ID, and then let's do department dot ID, and let's actually do employee dot department ID as department ID. And we'll just call this employee department ID. And we'll do this as department ID. And then let's do department dot name as department name. And I think that's a nice looking select. And we're going to grab this from our employees table, but we're going to join it to the department table on employee dot department ID equals department dot ID. Right?
You
And
forgot a
let's,
comma. Employee department
uh,
ID.
oh yeah, thank you. Right. And so because this is a one to many, an employee can only belong to one department, and we don't need this join table to keep track of. If in fact an employee could be in two departments at once, we would then need another table to keep track of that information. And now if I go ahead and run this query, we have department.name does not exist. So let's see here. It's called department underscore name. So we can, let's fix that to be correct. And so here we can see, well, let's just call this as employee. And again, you could imagine the way I've been building it out with the spreadsheet, you could imagine building this out the same way. And I'm just fixing a couple typos here. And so I can see that I'm connecting these two tables, right? And I'm connecting them because of this foreign key department ID. And if we pull up our data schema real quick and we look at employee, right? We have a department ID column that we've made a foreign key connecting to the department table. And without this, Postgres will not be happy, and I'm pretty sure the join. Uh, can you join? You might be able to join where you don't have a foreign key. Let's see here. Can you join without foreign key? I think the answer is no. Uh, I guess you can, but foreign keys give us all of that data protection. They improve performance. They do a bunch of other things. So you can do it without a foreign key, but you usually don't want to unless you really have to. So because we have this foreign key department ID connecting employee to department, and then we're using it here on our join, right, to join the employee to the department. Postgres can connect these dots and build us this result table showing which employee is in which department. Cricket, yes, sir.
So you create all the new files and you didn't import anything. So how you grab the data from like what's the path from the CSV file through the join 2, 3, how you get it?
Yeah,
You got no importing anything, just create the file and then it's automatic grab the data.
all of the CSV data, I have copy statements here in this sort of main SQL file that also creates the tables. And I ran this right at the beginning of class, and this created all my tables. and loaded in all of the SQL. And so now when I do /I tell pSQL to look at in this relative path for this SQL file. And because I'm already connected to the car shop database that has those tables and has that CSV data, I'm telling pSQL to execute these queries on this database. And it's the same thing as if I had just copied and pasted this into pSQL and then ran it. Yeah, good question. Tom, yes, sir.
So based off of what you were just explaining, between, the junction tables and the many to one relationships here, um, if we were to, for the junction table, rather than storing occurrences of ID to ID to ID, um, could we instead set the like a relationship function to an alias, so that way if we tried to do a query on it, it would automatically pull that row's data?
The short answer is no.
Okay.
Somewhere at the end of the day, I need to, because remember, if I really wanted to, I could car name, car make, and then I've got Toyota, Camry, and way down here, let's see, here we've got the same car ID. So again, we'd have the same Toyota Camry.
Right, you could just repeat data. I was just wondering if there was a way to basically create a pointer of sorts without going through complicated queries.
This is really the pointer.
Okay, okay.
Yeah,
Makes
yeah,
sense.
yeah. What ends up happening is once we get comfortable with joins, they will become a lot more familiar. And this is actually like one of the fundamental building blocks of SQL. And so this ends up, we would then build other things on top of this.
Makes sense.
Yeah. Yeah. No, that's a good question, but totally. Because, and again, the power I get with this is, let's say I want to change information about a car. Well, I can change some data about this car just fine. Like maybe I want it to be purple and I don't want it to be a Camry. I want it to be, a FUBAR. And I'm going to go ahead and I'm going to change some data about my service. And it's no longer a $29.99 oil service, it's a $229.99 oil change and awesome stuff. And because my data is organized separately and I've got these different tables, um, right, I have the service table and then I have the car table, which is floating around here somewhere. The car table, when I then run this query, and let's go ahead and run our car service. And it would sure help if, and actually Cricket, this touches on the point that you raised before. I have to, now that I have updated that SQL, I have to make sure to reload all of it now that it has changed. So I need to rerun this car shop SQL file. And now if I do select star from service, I see the oil price has changed. But in fact, we saw I hadn't before because I forgot to reload all of that CSV data. And so now I can run this join query. And right, we see in all these cases, this has changed. Right. So if I'm like a massive business, if I'm a grocery store and I want to like change the price of cereal for every store across the nation, by organizing my data this way, I can do it, and then it all kind of stays connected. And again, the purpose of this join table or junction table is really to keep track of a many-to-many relationship, because let's filter and have our query get this data just for one particular car. Right? And so I can see that my Toyota of model Fubar had 2 services. And if I didn't have that join table, that car service table to keep track of when a car gets a service, it would be impossible for me to keep track in my data of having one car have many services. Or alternatively, if I want to find out all the cars that have gotten an oil change, I can add a where clause to my join as well. Right? And I can see all the cars that got the oil change. So I just want to pause and check in here and see what questions folks have and what people are curious about, because I know I've been jumping around a bit. Tom, yes, sir.
To expand on Alex's question earlier, group by seems to be a little bit finicky. Is group by something we can utilize here with joins as well?
Yes, we absolutely can. Let's say, let me put this in a new file. Let's go ahead and copy this, and let's go to joins because this way I can play around with it a bit more. And, let's see how many cars got an oil change, right? I want to see how many cars got an oil change. So this part filters for oil change service. I'm going to need to add a group by. And let's group by service.id. And actually, let's change this a bit. Let's see how many of each service has been done. And I'm not explaining that very well. So for example, like oil change, 4 cars, brake inspection, 2 cars. Right? And so let's say, and let's in fact do this from scratch. I want to figure out how many of each service has been done. So I'm going to want to see, let's say service.id and service.name. And let's see service.price, because why not? And I'm going to want to do some sort of count as, let's call it purchases of service. And we'll start with our services table. But how do I get from a service to the number of services? Well, I've got service over here, but I need to connect it to car service, right? Because each of these is a single purchase of a service. So let me go to I've got a lot of join files here. So we are going to join car service on service.id equals car service.service ID. And let's group by service. We could group by service name or service ID. Either one uniquely identifies a service. Let's do it by ID, right? So here we are going to group by service type, right? Unique service. And let me add the semicolon here at the end of this. And we probably will run into a typo as I've written this out. The syntax can get a little finicky, but let's see how we do. And indeed, column service.name does not exist. I suspect that's just because this should be probably service name. Let's check our name of service. So goes to show why, we use verbose names for learning purposes, but when you're writing code, I recommend keeping the names like short, simple, as consistent as possible. And as luck would have it, this join now works. And so I can now see how many purchases of each of these services occurred by using a join with a group by together. We could, in fact, we could add more on top of this, right? Let's also maybe order by purchases of service descending, right? And now I can get some really nice data as the owner of my company, and I can see which services are the most popular. And I just want to pause and see if folks have questions or are curious about stuff here. Because I know we're kind of combining stuff together. Yeah, great question, Tom. And so you guys can see how this starts to get more powerful, right? And you can add a where clause without a sweat. Like example of we only want to see services over $20. So let's say where service dot price is greater than or equal to 20. And I put the where clause in the wrong spot, which is a really common mistake to make and an easy one to make. The filtering actually kind of you need to put before the grouping. So you do select from a join if you're doing it, the filtering, and then the grouping at the end. And now we can see that same joining and filtering put together. And this is where you can start to do a lot of interesting things. Like we could join this on cars. We could join it to see drivers. Let's look at another join example, actually. Let's look at, let me actually look at our guide code here. So let's look at cars and license plates. And if we look at the cars and the plates, I see I have 10 cars and I have 10 plates. Let's build this join out, and then actually I'll talk a little bit about there's different kinds of joins. So we'll look at that and we'll talk about that in a second. So let's look at our cars and plates, and let me go ahead and make a new joins file here. And we're going to see the license plates of cars. Right. And just to kind of take a look at our data model, license plates is hiding somewhere over here, but we have a car table and a plate table. And so now, as we've learned, we can use a join. So we're going to do select, and let's just say car dot star. Let's see all the car columns, and from plates, let's look at the plate number. From car, left join, and we'll put it in the left join in just a minute. We'll say join plate on car ID equals plate car ID. And again, the way that I really think a spreadsheet is a good tool here, right? Because whenever I'm trying to, I have to think through joins. You know, I've been doing this for years, but trust me, I have to just draw it out sometimes, right? And so I'll also be like, all right, I've got a plate number and the plate ID, and the car has a plate ID, and then it's got like a make and a model or whatever. And I'll often just write it out like this, and I'll make up some stuff. Right? There is no Toyota Civic, but really this helps me visualize how I'm constructing my joint, right? That I want to connect car ID and plate ID. And you can do this on a piece of paper in a spreadsheet. Either way, I think the important thing is to try not do it in your head, because that's not going to work until you've been doing this thousands of times. So now let's go ahead and let's run our query and see how we do. And this is joins5.sql. And we can see all the cars, information about the cars, the drivers, and the plates numbers. Right? And so here we see, again, just another join in action. And again, we could add whatever filters we want, where car.year is greater than 2020. And we see now that filtering occur. So let me talk a little bit about this. There's different kinds of joins. And there's left joins and right joins. And we're about to kind of explore left and right joins a little bit with cars and plates, and cars and services. And there's a great diagram for SQL joins, and this is the one that kind of everybody uses. And I think we even have it in the curriculum somewhere. And so the same way I've been drawing out, different tables here in a visual way, in a spreadsheet kind of way, and we have these sort of three different tables that overlap. And over here, it's these two different tables that overlap. With SQL, there's a little bit of math behind it. And there's this term set, and a set is just a fancy name for a group of stuff. And so when we're looking at this, what we should think is cars and plates, like license plates, or maybe we have a car and we have a car service. And so this is where the order of from and join does start to matter a little bit, that you were asking about before, Alex, because what if I have more cars? What if not every car has a service, right? So depending on how I construct the join, I might see everything from column A plus the overlap. You can actually do excluding joins, which are a bit more complex. By default, if I just say join, it does what's called an inner join, because this is sort of the interesting part, right? Is where two tables overlap, but there's different ways of doing it. And so let's see this in action, and then we can talk about it a bit. And I think I'll just kind of leave this up as I do a little bit of writing of code. And we'll kind of, it's going to get a little squished, but we'll leave it over there. And let's go ahead and clear this. And let's just throw a left join on this query and see what happens. And not much happens because every car has a license plate, right? If I look at my data, 10 cars, 10 plates, each car has a plate. And if I change this from left to right, it really doesn't make a difference. But not every car has been serviced, right? I've got 10 cars. Well, if I look at services, it actually looks like every car might have been serviced at least once. But let's make it so car number 10 has never been serviced. So let's get rid of car number 10 from our data. And let's get rid of car number 4. So now, right, if I look at this car ID column, car number 4 has never been serviced. Car number 10 has never been serviced. So we're actually going to have a difference. And let me go ahead and reload. Our SQL. And that should do it. And let's double check that my data is correct. Let's do select star from car service. And indeed, I don't see car number 10 or car number 4, right? And in fact, let's do where car ID equals 4, and there's none, right? And there's no car number 10. And indeed, if I do select star from car, I see that I've still got car number 4 and car number 10 in there. And now our join, our left versus right join, is going to get a little more interesting. So let's just go ahead and let's do select, how about car.id, car.model, car.make, and let's do car service.car ID and car service dot ID as car service ID and car service dot service ID. Now let's select it from our cars. And let's say, let's start out with a plain old join. And let's join car service on car.id equals car service dot ID dot car ID with the join syntax that we've come to know and love. And when I run this query, well, I have a typo and it looks like it is here on line 11 because I'm missing a comma. And let's run it again. And I see a bunch of cars, a bunch of makes, a bunch of models. If I look here in the ID column of my cars, I don't see car 10 and I don't see car 4, right? And in fact, if we do where car.id equals 4, we see nothing. Or where car ID equals 10, we see nothing. And that's because a default join is what's called an inner join. And it's looking for where the two tables that we're joining overlap. Now, a left join, which we're about to do, will take everything from the car table, whether it's been serviced or not. So we will see those missing cars reemerge. So we'll comment out the car ID and let's change this to a left join. and run this and see what happens. And now indeed, I see my car with ID 10, my car with ID 4. Note how Postgres has just created null values for these result row columns because that car has not been serviced. Right? So this is a left join. We're getting all the cars, whether it's been serviced or not. Now, if I do instead a right join, there we go. We're going to see all the services, and we won't see any of the cars that haven't been serviced. Right? So in fact, let's add a service. We'll call it 4. We'll call it service no car has, and it will cost a lot. And let me go ahead and reload my CSV data by reloading the SQL file with all of the tables and everything else. And let's make sure that the service table has been updated correctly. And let's run our left join just for fun to remind us of what we saw. Well, actually, we won't even see service no one has because I need to link car service to service. So let's in fact, let's throw in another left join. Left join service on car service dot service ID equals service dot ID. And let's over here, let's do service dot name of service. And now if I run this, we see the name of the service, right? So we have 2 left joins happening. Watch what happens if I flip this to a right join. So what do we see now? We see the service no car has, even though there's no car service data for it and there's no car, because our join is doing everything on the right side of the join. And we don't see car ID 10 or car ID 4. So most of the time, we want the inner join, we want the overlap. Maybe honestly less than 10% of the time you will want a left or right join, but it is really fundamental to how joins work, so it is good to know. And that's really the last big thing to cover here. We've really dove deep into joining. We've seen 2 joins in action. We could indeed do a third join. We can sort of continue this trend. We have, the make, model of the car. Maybe I also want to see the car's driver. And I believe it's car dot driver to driver dot ID as car. And we don't want the as, excuse me. And let's say driver dot first name as driver name. And let's put the driver name right after the car ID. And fingers crossed, this query will run. And let's see here, driver.firstname does not exist. So let's take a quick look at our drivers. it's just plain old name, right? Employees have first names, drivers just have names. And let's give ourselves a little bit more real estate to see this. And so now I've got 3 joins going on, so I can see the cars that have been serviced, the names of their drivers, and I could do whatever sort of filtering or grouping I want to here. Maybe I want to order my model. Maybe after the model, maybe I want to order actually by name of service and then by model. Right. And so now we can see all the cars that got what service organized. Um, so this is really sort of the conclusion of SQL, and joins, as you can see, are really bread and butter. There are a lot of good questions around, isn't this a lot of complexity? What ends up happening is once you start getting used to this, it becomes very flexible and dynamic to make joins. But also we'll see later on with Python and Django, though you can do this with SQL too, you write the query once and then you save it and use it, and you can kind of like sort of the same way we write functions, right? So we can combine these things together. So what questions do folks have? What's on people's minds? What might be good to kind of go over with regards to joins? Tom, yes, sir.
When would you want to explicitly create a junction table versus having a join query generate one for you?
You need to make a junction table, or as it's called, a join
Or,
table,
yeah,
whenever you have a many-to-many relationship.
I'm sorry, I think I misspoke. When would you want to use a query to populate a table versus um, having some sort of external input via like a seed CSV or direct input via user input or programmatic input?
Yeah, it's a good question. So the thing to remember is under the hood, it's always SQL inserting data into tables. Um, like if I go over here to this car shop SQL and this copy operation, under the hood, this is doing a whole bunch of insert statements, right? And so the short answer is, most of the time these days, if we're building a web app, probably the framework we're using on the back end has some tools to make it easier to write the SQL for us. Sometimes it's more complex, like it's called an object relationship mapper, like an ORM. Sometimes you might have Python code that you write SQL as strings in that Python code, and you kind of use it as functions you can call. Hopefully that helps a little bit. And when we get into Django, I think we'll kind of see that in action.
Gotcha. Okay. Yeah, I was just trying to tie the two together and see how, one would talk to the other and when we would, explicitly need to tell SQL, hey, put this data here versus saying, hey, here's an abstract way of taking this data, converting it and splitting it off and doing whatever with it in the database.
Yeah, I would say the short answer is we are always going to have to get into the details, even if it's only to do it once to write a function to help us. Um, what other questions do folks have, and what might be good to go over with joins or with any of the SQL stuff that we've been covering today? Okay, cool. Gentlemen, thank you very much. Let's wrap up here. Um, SQL joins are definitely your friend. We've covered a lot of ground here. We've seen a lot of different kinds of joins, left joins, right joins, um, and how we can kind of combine these things together. Let me go ahead and stop our recording.